Hi friends, in today's video class we will discuss the meaning of coefficient of performance and what is its formula. Coefficient of performance of a refrigerator is nothing but the desired effect. It is the ratio of the desired effect. Here refrigerator, the desired effect is nothing but cooling. That cooling effect or heat extracted from the refrigerator, that is desired effect. So it is the ratio of desired effect to the work done. We know heat can be flow from higher temperature to lower temperature without application of any external work done. That means heat, suppose body is at higher temperature, body is at lower temperature. This is higher temperature, this is lower temperature. So heat can be flow from body at higher temperature to lower temperature. But reverse can't be possible without addition of any work done. So to do so, to flow heat from the lower temperature to body at higher temperature, we need some work. So work is to be done on that system. So in refrigerator, to flow heat from the lower temperature to the higher temperature, we need work. So work is to be done. For that we have the compressors. So by using the compressor, we will do the work done and we will transfer heat or flow the heat from body at lower temperature to the higher temperature. Now come to the CO2. This is nothing but cooling effect by water. Now look at this figure. So this is the refrigerator. This is the body at lower temperature. That means inside that refrigerator. This is surrounding body at higher temperature. That refrigerator, inside that refrigerator is known as sink, and the atmosphere is known as source. In a refrigerator, remember always the sink is at lower temperature because we are maintaining the temperature below than the ambient temperature. So definitely the temperature of the sink will be less and the atmospheric temperature will be more. Consider your domestic refrigerator. Inside the refrigerator we are putting the things. We are putting the vegetables, fruits and food material inside it. For what? Now we are maintaining, we are to keep these products cool. So we are extracting heat. We are taking away the heat from those products to the atmosphere. That means atmosphere temperature is obviously more than that temperature maintained inside the refrigerator. So sink temperature of refrigerator is lower than the source temperature always for the refrigerator. This is the different case from heat engine and heat pump. So for this refrigerator, to flow heat from the body, to take away the heat from the body at lower temperature to the source body at higher temperature, we need work done. So according to the first law of thermodynamics, what is work done here? Work done is nothing but difference between heat flow. For this system, Q1 here, Q2 we are sending the heat temperature. So for this system, what is work done? This is nothing but Q2 minus Q1. Obviously Q2 will be more than the Q1. So Q2 minus Q1. So what is the cooling effect? What is the desired effect? Now this is the desired effect. We will take how much heat? If we will take more heat from the refrigerator, then more cool, we will feel more cool there. So this is the desired effect or cooling effect. This is Q1. So desired effect is nothing but Q1. And what is work done? We have calculated according to the first law of thermodynamics, that is Q2 minus Q1. Q2 minus Q1. So this is nothing but COP of refrigerator, coefficient of performance of the refrigerator. So this is the formula for coefficient of performance. Now we will write down in terms of temperature. We know what is Q1. This is MC T1. Mass of the refrigerant, C is the coefficient specific heat, T1 is the temperature of that system. So MC1, that is Q2, that is nothing but MC T2. Now put this value here. So what will come? So COP will be, in place of Q1 put MCT1, in place of Q2 put MCT2 minus Q1 MCT1. So take common MC here. So we take common here. So that will become T2 minus T1. Now this M and C will be cancelled out. Now what will remain? T1 by T2 minus T1. So in terms of temperature, so coefficient of performance can be written as T1 by T2 minus T1. If you know the temperature, so if you know the heat, you can find out the COP of the refrigerator. In today's class, we have discussed the meaning of coefficient of refrigerant and we have derived the formulas in terms of heat and in terms of temperature. Thanks for watching this video. Thank you.